All right, hi everyone. Today I'll be doing the exercise from chapter 8, tutorial number 1. It starts on page 395 and it's like the pipe thingy. So let's start by first taking a minute to just think about like where we would approach this, how we would approach this if this was on the test or on a quiz. So in this case, you could start two ways basically, either from the top part down or from the bottom part, the squarish bottom upwards. So in this case, I think it's always easier for me to work from the bottom of the long shape. So I'd rather go from bottom curve upwards rather than going from bottom to a longer distance upwards than going from side to a longer distance sideways, which you would have to do if you start from the circle, if you start from the disc on top. So let's start by just having a sketch open. So in this case, let's start with the base. We can get both the square and the circle in one sketch and simply extrude the square down and extrude the piping, or rather sweep the piping upwards. So if you can see on page 395, section BB, we're basically going to sketch that out first. So let's get it square going. Actually, it might be easier for me to just do line. Make sure you're in the right units first. Also, it's always good to check. Okay, down. Make sure it's vertically constrained when you're drawing a line. Okay, arc. It doesn't matter quite as much how accurate it is right now. We're just gonna get the general shape down. That's usually that's a way you can approach these things. Just get the general shape. If it's a really simple shape like this, get the general shape down first, and then start dimensioning it and constraining it into the correct sketch. So make sure this aligns. The dotted lines, make sure it aligns with the top. Just make things easier later on. Curve. Come on. Okay, here we go. Up. Curved. All right. So here's a really crappy shape, but now what you can do is go in and dimension this. So from top to bottom, you get, it says it's 85. All right. And the four rounded corners all have radius. It says 4x on the page. It says 4x, 4 times radius of 12. That means all four corners have a radius of 12. So let's do that. Radius 12. But instead of dimensioning each of these arcs individually, you can just dimension one of them and then select all 4 of them to set them equal to each other. That way you save a lot of work. You skip having to dimension 10 and 12 for every single corner. Okay, so now let's see what else we have to do. Okay. You also need to make sure it's centered in this case. So what we can do is, if we find the midpoint here, we can also select this midpoint by holding Control left click, and then center all these by hitting the vertical button. So we're centering the midpoints of the top horizontal line and bottom horizontal line with the center point. So if you hit vertical, now it's vertically it's constrained side to side, basically. Not fully yet, obviously, but now let's constrain it up and down. So click the midpoint, holding control, click midpoint on the other side as well. Oops, I clicked the line by accident. Just click it again to deselect, to unselect. On the midpoint, click. All right, now I got these 3 points selected. I can hit horizontal, and now it's a pretty nice looking shape. So it's still blue. So what's not defined, right? What's not dimensioned? You can just click around, click on a shape or a point or a line, and drag it around to see what's wrong with it. So let's see. Okay. Okay, so the arcs don't change, but the shape does get pulled horizontally. Basically, this width and this width, the width of these two lines are changing. So what we can do here is to just click on one of the sides and click on the side that we dimensioned already. So which is 85, right? So we click on this side and this side. So if we make these equal now, let's see what happens. All right. So nothing seems to move, but still undefined. So what is up? You might have to select more sides to set them equal to each other. So let's go back, Control Z, select this, Control, select, 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 and then set these equal to each other. Now it's over constrained, perfect. So when it's over defined, you'll get this, basically it highlights everything in yellow, and you essentially have to undo some of the dimensions or constraints you applied to result in this over definition. So since I set all of them equal to each other, I can get rid of some of the equal signs that I've set. So I can get rid of this one maybe. Okay, there we go, nice. So all I need to do was select 3 sides. The more you know, I guess. So now this is fully fixed. Now we can move on to the next part, which is the inner circle with the outer circles. Let's do the inner circle first. The small circle has a radius of 44. The top has, the outer circle has a radius of 60. So instead of making 2 circles, we can, I don't know if we can sweep a thin. Okay, yeah. Let's just make 2 circles to make it easy for ourselves. Then we can sweep that area upwards using the sweep feature. So inner radius of 44, perfect. And then click center again, and outer radius of 60. All right, so drag these out, make them look pretty. It gets really confusing if you just let all the dimensions layer up. I like to organize them into these, into a nice looking outline, outlay. So let's now do the 4 small circles on the corners. So in this case, since it doesn't really specifically give you dimensions as to like how far the small circles are from the top and side, you can assume that they're concentric with the arcs. And you can sort of tell by just looking at it that like it's most likely concentric, even though the arc is pretty small. It's reasonable to assume that it's concentric. So you can just type on these circles and type on the center point of the arc and make a circle from there. So that is a radius of 12. Perfect. So that's already fixed because we started it on the center point of the arc. So I believe it automatically okay, so it just constrained it there. Makes it easier for you. So now you can just go through and do this 4 more times, or you can make 3 circles and set them, constrain them to all be equal to each other, or you can pattern this. But in this case, since we already have the center points ready for us, it's easier for us to just make the circles, make 3 more circles and set them all equal to each other. If there were more of these small circles, I will use the pattern feature. But in this case, we already have the points to click on and drag out a circle. So it's much easier for us to just make 3 circles, hold down Control and left click on all of them and then set them equal to each other. There we go. And that's our base. Let's quit. We can just go directly into extrude boss. So what we can do here, you can use one sketch to, you can apply 2 features to one sketch. Okay, that's essentially what we're going to do here. So first we'll extrude out the square part and the circle part downwards. So make sure you have selected contours box highlighted. You hit that, and make sure you also hit the outer ring as well, because when you're sweeping upwards, we're gonna have a missing ring there basically. So make sure this is in the right direction, extruding downwards so it doesn't overlap with your sweep feature, which you will do using this this ring here, this ring shape, since this is the only ring shape. So this ring right here. So we make sure it's extruded the right amount, which is 12, I believe. Yep, check. All right. So now, notice how the sketch disappeared. I want to make sure that we can still select the sketch. Otherwise, we can't really pick it. We can't really pick a part of the sketch to sweep if we can't see it. Well, if SolidWorks can't really see it because we've hidden it. So make sure to left click and hit the eyeball to show. We can right click and hit the eyeball to hide or show again to show. So left click and right click both works. Just make sure you click on the sketch. So now, as you can see, the sketch reappears. Now I can use this to sweep upwards. But as you know, as you learned this week actually, so sweep feature requires you to have a path, right? You don't even necessarily need a circular profile to start, because this way you can just click circular profile. It would automatically assume that you're sweeping a circular shape, and all you need to decide is to pick the diameter. Yeah. Oh, and I guess you can also use a thin feature as well. So you didn't even need to make the inner. You didn't need to make the outer circle. I'll show you the different approach that you could have taken. Again, there's multiple ways of doing this. If you get the right part at the end, there's no wrong way of doing it really. As long as you define everything and don't use the fix constraint, and that should be fine. So before we do that, we need a path. We definitely need a path. That's the thing we definitely cannot skip over. So let's see. We have to start a sketch again. Sketch. So in this case, we want to, because we did this first sketch on the top view plane, to get a side view plane, we can either select the front view plane or side view plane. So to get to your axes, origin, and plane, you got to open this thing right here, click on the arrow, and it opens this drop-down menu. So now you can select to sketch again on the front plane, top plane, or right plane. So in this case, the front plane and the right plane both works. I'll just go with front plane because it's facing me already. Control 8 to get it to fit in my, to get it aligned in my view. It might not be Control 8 for you, but holding Control and hitting 1 through 8 gives you different views of the shape. So now we just need to see what path this pipe takes. So it goes up 80, and then it transitions into an arc with a radius of 90 and overall height of 75. So I'm getting this from either the tutorial picture, chapter 8 tutorial 1 picture attached on the modules page or on page 395. So let's zoom out a little bit, drag up. Starting from the origin point, should be fine. Oh, whoops, hit line first. Origin point. So you go up by 80. 80. Oh, whoops. As you can see, it's slightly off center, not vertical. So I had to fix that before we get out of the sketch. In an arc of 90, arc radius of 90. Enter. Oh, click, left click. So yep, that should be good. Oh no, wait, there's also a small, so it goes from vertical line to an arc, and then to a small chunk of straight line at the end. I didn't see that. So straight line right here. All right, so this is the general shape. Again, for these simple sketches, you can start out just by getting the general shape down and then constrain them, dimension them into the correct sketch, and then making sure they're fully defined afterwards. So first of all, screw saving. We make this vertical. So now that is fully defined. So is that one. Okay, all I'm missing is this now. So what the dimension that they gave us in the book is that going from the bottom of the arc to the top of the straight line, the dimension is 75. All right. So, okay. And it also says that going from the bottom of the line to the round, to the bottom of the round disc. So going from, let's see, I don't know if you can see this, but going from here to here. So going from this distance, basically the length of this line is 20, okay? The length of this line is 20. So also it's much easier to do CAD if you have like the picture put up on a different monitor, if possible, or have them put up side by side. It's always easier than having to switch back and forth between your tabs, like switch back and forth between your tabs. So dimension again, get this, and as we said earlier, this is 20, and that should make it fully defined. All right, perfect. So that is a fully defined sketch. As you can see, my sketch is all fully defined. You can tell because there's no negative sign. There's no there isn't a symbol that's parentheses dash parentheses. So it's like a negative sign. Having a negative sign next to your sketch, to the left of your sketch, basically means it's not fully defined in some way and somehow. Also, we do go over your sketches. We do download your part models, and we look through your constraints to make sure you're not using fixes. Using fixes will get points taken off of your part model because that's not the correct way of typically the correct way of designing a model. So make sure you define everything not using without using the fix feature, the fix constraint. So now that we've drawn finished our path sketch, we can go into features, swept boss / base. So for the face, I can choose the inner one. Oops. Ooh. Okay, oops. It's not a guide curve. Clear, whoops. So you want to select the path, which is this. Okay, so you definitely don't want this. Get rid of that. Delete. So you just want the, okay, so I guess you can't select just a face. I thought you could. What the heck? Let me delete this and try from our sketch. That is super weird. Well, I guess you can't do that. Okay, so I guess it has to be its own individual sketch for you to sweep just that part of the sketch. I guess it doesn't distinguish between different areas, unlike extrude. So in this case, everything's still okay. Let's try the alternative method. which is much easier. In this case, so we select circular profile. We determine how wide this pipe is. In this case, it is 44. The inner diameter is 44. So let me do that. 44. Oops, 44. All right. And then select the path. All right. So now we have a filled in pipe, right? We don't want that. So we want to hit thin feature. Basically, it gives you like you can either here. Let me make this more. Let's make it easier to see. So you can either have a thin shell, basically, going out from the circle of radius 40 with a diameter of 44 millimeters, or you can have a shell with the thickness extended like inwards. So you can play around by just clicking the reverse direction button. So in this case, watch like where this shell, I guess, extends to. So in this case, it's extending inwards. So if the radius of the outside, basically the radius of the outside in this case is 44 millimeters. Sorry, the diameter of the outside is 44 millimeters. And if you click the reverse button, now the diameter of the inner circle is 44 millimeters. So in this case, we want the inside to be the inside diameter to be 44 millimeters and the outside to be 60. So doing some quick math, the difference, the thickness of the thin shell that we have here should be 8. So as you can see, it lined up with the sketch we made visible. So basically, with the shell being 8 millimeters, it's adding 16 in total because it's 8 on both sides. The total diameter increase would be 16. And 44 plus 16 is 60 millimeters. So that is in accordance with the drawing that's given to you in the book. All right. So we took a detour, but it's all going to be good. It's all going to be okay. There's multiple ways of doing this. So it's all good. So again, to make it less confusing, you can just hide the sketch. Basically only show a sketch if you need to use it. In this case, we couldn't use it. So it's a shame, but at least it helped guide us. It helped confirm how thick our thin shell should be. So now our last part is just to make a sketch on this plane and make the other end, the circular disc ring thingy. So again, hit sketch. We'll hit the plane and hit sketch. Control 8 to get it aligned so that the sketch plane faces you. It's Control 8 for me again, but it can be something else for you. I think it should be Control 8 for everyone, for most people at least. So something cool is that you can use existing edges of your part as reference. So in this case, if we go, let's look at, so the diameter is the same thing, 40 and 60, I believe. 44 and 60. Whoops. 44 and make it concentric. See it automatically, if you make another circle from the same center point, it automatically applies a concentric constraint. So in this case, 60. All right. So now this whole thing moves, right? You don't want that. So you want to somehow, you want to use your existing edges, the existing edges from your part to constrain your current sketch, because like we're not really at a convenient Actually, we definitely could just make a dimension it in terms of, oops, sorry, my notifications. We can definitely dimension it and fully define it by saying a dimension to the origin. But in this case, you can also use the edge. So let me show you. You left click on the inner circle or outer circle, and you left click, left click, hold down control, left click. And then if you just hit concentric or co-radial, because it's the same, co-radial is basically concentric plus the radius, plus now the radii are also constrained, also equal to each other. And not only do they share one center point, as you guys probably know already, the radii are also the same. So I'll just say concentric for now, and there we go. So basically, we set we've related this new sketch circle we made with our old part edge, with the edge of our old part. So let's see. It still shows a negative sign here, but down here it says it's fully defined. So sometimes it takes some time to process. SolidWorks, I guess, lags a little bit. So once you leave the sketch, this thing should fully update and the negative sign should disappear. Okay. Actually, in this case, we don't even need the outer diameter, the outer circle of 60. We can just make the largest circle, which is 90. All right. And then we're practically almost there. So Control 8 again, get it aligned, fix these dimensions up a little bit. Make a circle. So now we need to make 4 more circles. In this case, it's one circle directly on top. It's basically one circle at every 90 degrees. So 0 degrees, 90 degrees, 180, and then 270. So make sure the dotted lines show up, because that means, as you can see, like the white vertical symbol, it means you're vertically aligned with the center point of the circle. So let's make a circle here. It should be, it says 4x, radius of 10, diameter of 10. So diameter 10, okay. And we just need to fix the circle. So select the inner points, select the center point of the big circles, make them vertical. So now it's horizontally constrained, but it can still move vertically. So let's see what distance it is away from. Okay. So it says here that these 4 circles are sitting, they're sitting on a larger circle of radius 74. That just means the center point is sitting on the edge of a circle with diameter of 74. So radius of 37. Sorry guys, I'm having a lot of trouble with radius and diameter today. So it should be 37. The radius is 37 from the midpoint, 37 millimeters. So we can set dimension here. 37. And this fully defines it and will ensure that this circle is sitting on an imaginary circle with diameter of 74 millimeters. I think you can also just make a, I don't know if you can make a construction circle. Let me see. You can. So you can also make a construction circle and then just put your circles on this construction circle. So that's a different way you can do this as well. Again, there's many different ways of doing CAD. Many correct ways of doing CAD, I should say. So now we just have to make 3 more, or in this case, I'm feeling sort of lazy right now, so I'm just gonna use circular pattern. I think you'll learn about this in the next chapter. But it's basically the same concept as linear sketch pattern. So drop down menu, circular pattern. Okay. parameters, you guys choose something for it to circularly pattern about. So in this case, I can choose basically any circle here. I'm basically telling SolidWorks that I want to pattern the circle around, pattern the smaller circle around this circle. So I click this. Nope, that is not it. What the heck? Delete. No. Maybe I want me to click a point. Sorry, let me try this again. I'm gonna use this in a little bit, so a little bit rusty here. Okay. So entities to pattern, it knows what we want to pattern this thing. But the parameter it wants us to pattern around is not really correct. Oops, I accidentally added an extra arc to this. You don't want this. Delete. Make sure you're selecting the right box. Delete. What the heck? Delete. I don't know why it's doing this. It's being so fussy today. What the heck? Oh my god. Oops, one thing. Again, a lot of this is just playing around. It's all the practice. Clearly, like I'm out of practice too. Let's see. There you go. There you go. Okay. So for some reason, the center point was at the origin. Like, what the heck? I don't know why it's like this. Okay. So to restart, circular. See, like I played around with it and I got it. Nice. It just takes some trying. Sort of annoying, but okay. So the parameter thing is selected. You can just choose this as our parameter arc1. So it's, as you can see, the yellow outline is basically the pattern that it's assuming. That's like previewing, basically. It's a preview of what the resulting pattern would be if you just hit check. So we don't want this, obviously. So come back here again, circular pattern. We want to hit this now. So for some reason, this point here, this arrow is pointed at the origin. So I guess this is what happens when you pattern away from the origin. It just assumes, it just centers at the origin. So you have to click on this blue dot here at the tip of this arrow, at the tip of this yellow, just drag it to the center point about which you want to circular pattern. So in this case, the preview seems pretty right. It's basically, if you look at the parameters, oh, so this is not correct. Oh no, this is fine, this is fine. So equal spacing, 360 degrees. Okay, so we have equal spacing checked, which means if there is 4 counts of this pattern, four instances, and instances includes the original one that you're going to pattern. If there's 4 instances and you split them between 360 degrees and you hit this equal spacing, it's going to put an equal number of degrees between each of these shapes. So as we increase these, as you can tell, they'll equally space them out in terms of 360 degrees. You can always decrease this and have it, if you just want to pattern like a certain portion of the circle, you can always decrease this. Let's see, like 200, for example. Now it's like pushed all the way over here. Essentially, you're only splitting these 6 instances across 200 degrees. So in this case, we want 360 and we want 4 instances. Sheesh, that took a while actually. All right, let's see if these drag around. So these can move around, right? We don't want that. Okay, so hit the center point of the circular pattern, which is this. Hit the center point, coincident. Whew, that took way longer than it should have been, but practice makes perfect, guys. No one's perfect. Take it easy on me. And then you just extrude. Okay, so it says 12. It's already saved from last extrude. In this case, you don't want to extrude these 4 circles. You want them to be holes. So you hit the selected contours and you unselect these holes. And now the preview is more accurate. And you also don't want the center circle. You want this to be a pipe, right? You don't want it to be blocked. So this preview looks fantastic. Now let's hit check. And ta-da, we're done now. Make sure to specify your shape, your material before you submit. I think you might have to set it to a certain material setting. Don't forget that. And otherwise, this is the final part, I believe. Yep. If you have the book, if you go through the examples, it'll tell you about the thin feature. You can hit a thin, that would work. Yep, I'm pretty sure we covered everything. Okay, nice. So they also used circular sketch pattern. Okay, so what they seem to do is they extruded a disc, like a donut disc first, and then they added the small holes on top. And if you follow the direction in the book, they made this entire disc, this surface first, and then they went back to add a third sketch to add these circles. And then they use extrude cut to punch holes out of these. So again, there's multiple ways of CADing, and both ways are correct. A lot of ways are correct, actually. So it looks pretty nice. Yeah. Nice. Maybe make it you can change the appearance of this pipe. Let's see what we can change it to. You know what? I think we should also go over the other way of doing this as well. So by dragging this bottom bar here, you can choose to suppress. Basically, if you drag this line above the parts you don't want to be shown, SolidWorks is going to pretend that they're not there. Yeah, so basically they don't exist because you can pull this thing. It's basically like unwinding, temporarily undoing some of the things you've done to make the shape. So I'm just gonna, you usually won't need to use this thing. You usually won't need it, but I'm just using it to hide a few portions of the parts so I can demonstrate the other way that we could have done it. So I want this to show again. So now our initial sketch is showing. We can hit smart dimension. Oh no, we can hit sketch on the surface, Control 8. So we're gonna sweep. Come on. We're gonna sweep an area this time. What the heck, whatever. 80. No, wait, it was 44. And then this is 60. Dimension this. Oops. 60. All right. Now we have this. Put out. And then we hit sketch. Oh, whoops, not the right sketch. So we want to hit sketch without selecting the sketch. We want to hit the sketch button without hitting sketch the sketch we just did. Otherwise, it'll just go back to the sketch we exited from. So hit sketch, and then hit the front plane or right plane. We used the front plane last time, I believe. So we're going to use the right plane this time. It doesn't matter. Control 8. Make the shape, make the path. 80. Arc. 90. Okay. And then a straight line. Oops. What the heck did I do? Control Z. All right. Cool beans, cool beans. For this arc, oh, I made 2 lines by accident. Whoops. So this is fine. 80, this is already vertically constrained. 90 is fine. Now we just have to fix this distance as well. That is 75. Cool, cool. And this length here is 20. Okay. All right. So I think it also, last time it did it for us automatically, but this time, as you can see, by just moving this around, that we're missing a dimension or a constraint. Because everything, we've done all the constraints they asked us to. We've done all the dimensions they've given us. We can apply, we can assume that this is tangent to each other, and this should fix it. This should fully define it. Now we can leave the sketch. Loading, loading. Oh, please don't crash. Okay. Oh no, what the heck? All right, guys, I guess you should save. This is very unfortunate. That is very annoying. I don't know if it automatically saves. I don't think there's auto save though. So this might be it. Man, SolidWorks. Why you gotta fail me like this? Why you gotta do me like this? So drag this over. All right. Let's just quickly do this again. It's not gonna be accurate, but whatever. I just need to get an example through. So it doesn't matter what it is exactly. All right. Seven. All right. So I want this to be down. So pretend this is like the bottom plate, whatever. All right. All we did was sketch on this one. We made a 44. Let's do like, I don't know, 50. All right. So we say inside of this area. Again, this is not accurate. This is just for demonstration purposes. And then make sure you don't select the previous sketch. Otherwise, when you hit the sketch button here, it's going to go back into the sketch. So sketch, open up the drop-down menu, hit the right plane, Control 8, do this, make a line, 50, what is it, 80, 80, 90, and then make a line. Do you see the yellow tangent constraint that comes up? It automatically, SolidWorks can assume sometimes what you're trying to do. So in this case, I'll just leave it be 20. And now we only have to fix this distance here, which was 75, I believe. All right, donezo. So the other thing you could have done was the features, sweat boss, hit the sketch. Nope. Oh yeah, okay. So it automatically selected our last sketch as the path. So it makes assumptions frequently. SolidWorks makes assumptions. Sometimes they're wrong, sometimes they're right. So when it's right, it's very convenient. And then we select the sketch. There you go. That's the other way you could have done it. This also makes the piping, as you can see, very nice, very nice. And then you could have, again, went on top here, and then sketch your circles. And this is all extra. Make sure. So you can use. Do you guys see how like it lined up automatically? My sketch circle with the part, Control 8. If you just hover around the side, it lines up. It snaps in to the previous one. So if we just dimension this in the right shape, we can snap this in to the existing edge we have already. Oh, okay. So we can't snap it in just by dragging over it. We have to just, again, what we did last time was click on this, left click on this, click Control, and left click on either of these two edges. We did the inside edge last time. Let's do the outside edge this time. Let's do concentric. And now this is fixed. Okay. And dimension this, whatever. Whatever. Don't do this for homework, obviously. This is just for demonstration purposes. Extrude this. What the book did was this. They did 12, whatever. I mean, I did 10 on the bottom, so just it's not accurate. 10. Yes, this is what we want. Yep, it's pretty good. All right. And what the book did was, after they've done this, they then drew on the circles on top here. So let's try the, oh, whoops, I did sketch. Let's try the construction circle method. Construction circle for construction, perfect. Okay, and make sure this is fixed. Otherwise, your circles will not, your small circles will not be fixed as well. So the reference you use has to be fixed, preferably. Make sure this is dimensioned. Also, something you shouldn't do is click on the shape and then change the dimension here. If you change dimension here, it's not, it gives you the right length. It gives you the right like parameter. It gives you the right dimension. The shape will be the right dimension. So if you want this to be like, I don't know, 30, and you hit check, this circle will be 30 millimeters in diameter, right? But I mean, in radius, a circle with radius of 30, but it's not dimensioned, which means even though it's currently 30, you can still drag it and change its dimension. And now the radius is around 60. So you don't want to just do that. You want to hit smart dimension and then actually give it a visible number on the screen. So in this case, 60. Okay, Control 8. The circle seems a little bit misaligned. Actually, no, it seems fine. It seems fine. Okay. Yeah, so this construction circle here is coincident with the previous sketch we did. The center point of the previous circles we made. Okay. Now let's try making this circle. Just what? 12, 10. In this case, let's just go with like 10. Let's make this smaller. Whatever. All right, cool. You can pan this around. Not mirror. Circular pattern. So arc it's highlighted in light blue. That is the correct shape. But again, it's pointing towards the center point. You want to drag this to the center. I think you can also just hit the construction line. Nope, you cannot. Okay. So I guess if you make a construction line, you can just add in these circles yourself. Hold down Control, left click. Oh, whoops, I just unselected that one. Left click, make sure they're all light blue, which means they're all selected. And you hit the equal constraint, and now they're all equal and on the same perimeter, on the same circle's perimeter. So this is the other way you could have done it. Then you can get out the sketch. You can use the extrude cut. I believe you can also use the hole wizard. Okay. If you're using the hole wizard, you just have to choose to make sure you're selecting the regular hole. And then for positions, select the face for the hole. Oh shit. Typo hole, blind. Positions. Oh, there you go. Oh, I guess you don't even need the outside circles if you're using the hole feature. You just need the points. But make sure a common issue was the points themselves were not fully constrained, were not fully defined. Thus, the hole you made can move around. So you want to make sure your point itself is fixed. So in this case, our point is fixed to the circle, which we have fixed onto the construction circle. So in this case, it will not move. As you can see, the sketch is fully defined. Everything's fully defined. So when you make the holes, these holes won't become screwed up when you change some dimension later on. So this is thinking like further down the line. This is just building good practice, good habits. So if you hit check, I chose the wrong hole. Edit feature. You can always go back in, select the right type of hole. I think this is fine. Download type. Okay, you can choose different end conditions. I could choose up to next. That would give you, will basically end at the next surface it hits. So this is a very handy tool. So it just ends at the next surface it hits. As you can see, this is a little bit, the shape is a little bit weird because I just BS'd it a little bit. But for demonstration purposes, this is fine. As you can see, this is the other way you can do it. Control Z again. You can also extrude cut, bam, bam. Oh, see, now you can select, if you can't select anymore, that's because you haven't clicked on the selected contours box. There we go, there we go. There we go. All right, the preview is fine. In this case, it's blind still. If we wanted to just, again, you can also choose to up to next, which means it'll end at the next surface. This is sort of messed up right now because of my poor dimensioning. But something else you can do is up to surface. You can click a surface that the hole will go up till. So that's another option you can choose. They're all pretty handy, honestly. And it's up to your preference. Many different ways, again, many different ways. And I think that's all I wanted to show you guys. It's a lot of hopefully helpful tips. It was sort of a long video. You can just play out 2 times speed, hopefully. I don't know what you're telling me. you this right now, but you probably will be playing this in 2 times speed or something. So yeah, hope this helps a little bit. Take care, guys.